Okay, so these are going to be the notes for objective 2.1a. 2.1a. And our topic for today is factoring. Basics. GCF and grouping. Now I'm expecting to move through this quite quickly. I will not write down every single thing. Okay, our instructional objective today, I will be able to factor polynomials using greatest common factor, GCF, and the grouping method. Okay, ready? Can I go? Please participate when I ask questions, okay? All right, again, I can leave you behind here. I really need my mouse. I'd like to have my mouse. Okay, so here we go. First box. GCF, which I just went past. Oops. Oh, too far. Too far. Try again. Okay, so we're going to start here with GCF. Definition. I don't want to give you a definition. You should know what GCF, the definition of GCF is. But what does GCF stand for? Okay, greatest common factor. All right, so that's just an acronym for greatest common factor. And factors are, what are factors? Well, they're not multiple, so it's not least common multiple, but it's greatest common factor. What are factors? Factors come from which operation? Addition, subtraction, multiplication, or division? Factors come from multiplication. So when we're looking for greatest common factors, we're looking for the largest factor that we would multiply to get the number that's being given to us. So 28 and 40, we're going to break it down into factors. One time I'm going to break it down into its prime factorization, or a product of its primes, so that we can find its greatest common factor. Now, I know you probably already see its greatest common factor, but sometimes I might, when you're on your homework, I think you have to find the greatest common factor of like 128, 210. It's not quite as easy to see those common factors. So what I'm going to do is just for this first one, I'm going to break them both into their product of their primes. So you say 28 is what? 4 times 7? But I would write that down. 4 I can break down as 2 times 2, right? Times 7. Would you agree that that is the prime factorization of 28? 2 times 2 times 7. Can't break 2 down, can't break 7 down. So those are prime numbers. Let's do 40. 40 is 4 times 10? Yes? And so 4 is 2 times 2, and 10 is 2 times 5. So I broke them down for this one time, just down to the basics. What is their greatest common factor? They have in common 2 and 2. So their greatest common factor is 4, because they both have a 4 in common. That's the greatest factor they have in common, 4. So you can always rely on that strategy, a product of primes, to help you find the greatest common factor. Let's move on to B, 55 and 21. Let's do prime factors one more time. What are the prime factors of 55? 5 and 11, and that's what we got, right? How about 21? Yeah, 3 and 7. Uh-oh. They don't have a common factor. Oh, but all numbers have a common factor, Mrs. Frame. What's the greatest common factor? Yes, 1. 1 times 55 and 1 times 21. That's as great as it gets. It's 1. Okay, so there we have it. All right, now you have a list of 3. And I always have advice when you start getting a list that's higher than 2 numbers. I look at the numbers that are closest together. In this list, 15 and 18 are close together, yes? So what I do is I see how far apart they are. What's the distance between them? So it's 3, right? So we'll check to see if 3 goes into that. Yes? 15 is 3 times 5, and 18 is 3 times 6. And does 3 go into 66? 22 times, right? So with this one, I would say that my greatest common factor is 3, and it can't be more than that because 15 and 18 are only 3 apart. So they can't have a factor that's bigger than that. Okay? All right. So those are our numbers. Let's go down to our variables. How do we find quickly the greatest common factor among variables? Imagine expanding out x cubed. Yes? X times x times x. How about x to the 7th? Right? We're going to do 7. Here we go. And then x to the 5th, right? So the greatest common, x cubed. They all have an x cubed to get. So what would be the fastest way? I like variables. They're easier to do. Yes? To look at the lowest exponent. Okay, because this one doesn't have any more than 3 to give, but all of them have at least 3 to give. So what's our greatest common factor for E? Y to the first. Y to the first. Okay? I'm over here, so I'm not writing. Sorry, people that are watching videos. Here we go. Letter F. Now it's a combo of numbers, coefficients, and variables raised to powers. So what? How far apart are 6, 8, and 10? 2. So I always check 2 because it can't be greater than 2. Will 2 go into all of them? Of course. So it's 2. And 2 what? X to the first. All right, so there's your common factor there. Could it be negative 2? Couldn't I factor a negative out of all of them? It could be negative 2x. We're not going to go there because negative 2 is not greatest. 2 is greater than negative 2, yes? But sometimes when we're factoring trinomials, I will have you factor a negative out. We'll talk about that. Okay, we're going to scooch down to the next set. You can see them, yes? Okay, what's your greatest common factor of your coefficients? 8, 1, and 1. 1. All right, and how many y's? Y squared. There we go. Greatest common factor is 1y squared, but we won't write the 1. Okay, last one. Greatest common factor of our a's. A cubed and our b's. Be careful. That's b to the first in the middle. So it's a cubed b, not a, I underlined the b. I didn't write a negative. I just underlined the b. Okay, so be really careful. All right, so just brushing off finding greatest common factor. Now we're going to talk about what is a polynomial expression. Is that the next thing on our list? Okay, so let's take a look at that. And I'm not going to give you a definition again, but I do want to talk about the different types of polynomials that we will be encountering during our quadratic studies. So first you have the monomial. I don't like to write the whole word. I just write the prefix, so monomial, meaning one term, a single term. So, for example, so we'll put some examples. 2x is a monomial. Do you agree? Single term. Okay. How about 5? Is that a monomial? Yeah. You know why? Because it's 5 times x to the 0. It's a monomial. Okay, how about negative y squared za? Yeah, it's a monomial. It's a single set of terms. You could be multiplying them, these different values, but it's still a single term. Let's talk about some things that monomials are not. X to the half power. We're going to put a little slash sign through that. This is not a monomial. Okay, it is not a polynomial because that says the square root of x, and our x's have to be unencumbered. Our variables can't be under a radical, and they can't be in a denominator. So another thing that is not a monomial or a polynomial would be like x to the negative 2, because that will put your x in the denominator. That's not a polynomial. That's rational expression. So you will not see half powers. You will not see negative. You won't see rational powers or negative powers. Not in a polynomial. Now, I might have you do some factoring just to test your skills with them, but they're not polynomials. Okay, the next one after monomials is a binomial. Of course, let's just do an example or two. How about negative 3 plus x? Guess what makes it a binomial is it's two terms separated by addition or subtraction. 7y squared plus y. Yes? Binomial. You get it. Let's do the next one. The quadratic that everybody loves, the trinomial. Okay, examples could be x squared plus 2x plus 1. That's a perfect square trinomial. I love those. They're really easy to factor once you figure them out. 3ab plus b squared plus c. Trinomial? Yeah, not quadratic. What a trinomial. Okay, just 3 terms. All right, and then the last category is a polynomial. We don't call them anything else. Poly meaning, what's the prefix poly mean? Many or multiple, many. Okay, poly means many terms. A polynomial will have greater than or equal to 4 terms. It might have 5, it might have 25. Hopefully not. But a polynomial is just more greater than or equal to 4 terms. And you'll start seeing cubes. So like x cubed plus x squared plus x minus 1. Okay, it's a polynomial. I'm not going to give you a bunch of examples there, but there you have a polynomial. It's a degree of 3 would be the lowest degree. Okay, the exponent's what we call a degree. This is a degree of 3 exponential, or sorry, a degree of 3 polynomial. This is a degree of 2. This is also a degree of 2 because the exponents here, 1 and 1 make 2, so that's a degree of 2 right there, the 3ab, and then the b squared is also a degree of 2, so that's a degree of 2. That's a quadratic. This is not a quadratic. No, it's just a polynomial, a trinomial. Okay, so there we have polynomials. Ready to move on? Okay, to the next box, to the right, to the right. Let's move to the right. I really have to stop dragging my mouse over. I gotta scooch that over so I can get this up a little bit. All right, so we're gonna start off with some information, factoring out a polynomial, factoring out the GCF. Okay, so what does that mean? It means this. It's breaking up a polynomial into simpler terms, and in this case we're going to call them factors. Such that when the factors are multiplied back together, they equal the original polynomial. We do this because when we end up adding an equation or an equal sign to say A, say it said 6t plus 18 equals 5 or something, we could solve it by factoring. Here, we would have to solve it by factoring because it's a higher order. This is a 7th degree equation here. So factoring is the only way to solve it. Letter B, if I were to turn it into equation equaling 0, has 3 solutions. 3. It could have up to 7 if it factored out to 7 different y's, but that one only factors out to 3, and we'll show you in a minute. All right, so let's take a look at A. In A, I'm going to write something that you probably are going to go, come on, Mrs. Frame, we know this. But I'm going to just make sure that I'm not assuming anything for today because I don't know where you came from as far as maybe you had a different math teacher, and I don't know if you came from Ratcliffe or Bogart or you came from a different school. So I want us all on the same page. So let's factor out the GCF. So looking at 6t and 18, what is their greatest common factor? 6. So you see it. All right, so what I'm going to do, just me, you don't have to do this if you don't need to, is I'm going to rewrite this out in factors of 6. So I'm going to do 6 times 1t plus 6 times 3. And you're saying I'm going to factor out the 6, right? So that would be 6, and I'm going to use the distributive property, times t plus 3. And this is a simpler set of terms. If I had this equal to 0, I would know that t equals negative 3. Immediately, I would know that. And we're going to get you to that point soon. How do we know it's true? If we multiply it back together, 6 times t is 6t, and 6 times 3 is 18. And I know it's completely factored on top of that because this factor, this binomial factor right here, t and 3, the only number they have in common is 1. So I can't factor it any further, so I know I got the greatest common factor out of that. Okay, you do B. What's the GCF, guys? Y to the y to the 5th. The greatest common factor. Okay. So if we factor that out, what are we left with? 1 minus y squared. 1 minus y squared. Why is the 1 important? And that wouldn't take you back to the original problem. You have to remember all the time that you have to be able to distribute back into this problem that you factored out, this binomial factor, and get back to the original. You have to remember that there's a 1 on that y to the 5th, and you're leaving it behind. It has to hold its place. Now, I already noticed that this needs to be factored further. Had the instructions said factor completely, I would not be done. The instructions for this say factor each polynomial by factoring out the greatest common factor. We did that. But I want, by the end of these factoring review lessons, for you to realize that is not done. And the reason it is not done is because this is a perfect square, 1 times 1. This is a perfect square, y times y, and this is subtraction. So to factor it further, just so you know, I'm looking for by the end of all these lessons for you to be able to do that this really is y to the 5th times the quantity of 1 minus y times 1 plus y. Difference of perfect squares, which is a special case. We'll do them on Tuesday of next week. This is okay for today because it said just factor out the GCF. Yes? So it's okay. But on the test, wouldn't be okay. All right. Next question. Now your teacher's going to be picky. Your lead coefficient in this problem is negative. Yes? The lead is negative, and we're descending 5 and 2 and 1. So when we factor out a GCF, if your lead coefficient's negative, I would prefer for you to factor out the negative. And what is their greatest common factor? 3 and a. So the greatest common factor is going to be a negative 3a in this situation. So when we factor that out, negative 3a, now we have to think, okay, so how do I get back to this? What am I multiplying negative 3a by so that I get negative 9a to the 5th? 3a to the 4th. Negative 3a times what gives me positive 18? Negative 6a. And negative 3 times what gives me, negative 3a times what gives me negative 3a? Positive 1. You'll notice that all of the signs inside your trinomial factor switched because we took the negative out. So all the signs in the trinomial factor switch. You went from negative to positive, positive to negative, negative to positive. Anytime you factor out a negative, that's always going to be the way it is. Okay, you do the next one. Quickly, quickly. So here we go. Greatest common factor is z. All right, so if I divide out or factor out a 5x squared z, how do I get back to 25x to the 4th z? 5x squared. How do I get back to 15x cubed z? 3x. And how do I get back to 5x squared z? 1. Nice. And we know we're done. Our trinomial factor here, 5, 3, 1. Nothing in common but 1. We're done. Unless we could continue to factor that, but I'm pretty sure that we'd have to put it in the quadratic to factor it. All right, so there we go. Now I'm throwing something new at you. And a lot of you will have the really overwhelming urge to immediately start distributing. But it is time for us to know that factors aren't always monomials. Sometimes they're binomials. This is a binomial. 5 times a number plus y times a number. The GCF of this binomial is a binomial factor of what? X plus 3. It is already partially factored for you. And you have to start training your eyes when you're factoring to look at the groups. Are the groups matching? In this case, your binomial factors. So let's call that a binomial factor. It's still a factor. Okay? So we would factor it out. So it would be x plus 3 times, if we take the x plus divide 5x plus 3 out of this, what am I left with? Divide x plus 3 out of this, what am I left with? Done. Factored. Finished. You do the next one. Okay, I'm going to call on somebody. What's the factored form of this? Go, Nick. What's your GCF? Okay. Times. You divided it out of this term. What's left? N. And then you divided it out of this one. What's the number in front of this group? I want to be able to get back to this. So I multiply that times that to get this one. What am I multiplying the A plus B times to get back to this minus A plus B? 1 minus 1. And there it is. So if you weren't seeing that negative 1, you might want to drop it in there so that you remember it. Okay, so that's factoring out GCF, even if your factor is not a monomial, but a binomial, which is important for the next section. So now we're going to quickly move into filling in the blanks on the next section, please. Okay, I'm kind of off the screen here. All right, now, so factoring 4-term polys by grouping. The grouping method. Step 1, always, fill in the blanks. Always look to see if all terms have a GCF. If so, factor it out. Always. Step 2, arrange the terms so the first pair has a common factor and the second pair has a common factor. Step 3, for each pair of terms, use the distributive property to factor out the GCF. And I call it looking for the magic. If you don't find it, you have to try something else. Okay? Step 4. If there is now a common binomial factor, factor it out. Example, I'm just going to underline the common binomial factor, x plus 3, as a visual, a binomial factor. Step 5, if no common binomial factor is found in step 3, begin again by rearranging the terms differently. I'm off the page and I don't want to scroll up. You have it there in front of you. I think there's more that it says though, right? Something about filling in the blanks. So it says check all combinations of terms. If no common binomial factor is found, so bino is found, the polynomial cannot be factored. Have to try something else. Okay. Helpful hint. Helpful hint. Here it is, the helpful hint. When factoring a poly, make sure to write as a product. Multiplication problem. Okay? When factoring a poly, make sure to write as a product. We are almost done and we are so close to running out of time. So here we go. Thing we probably really needed to practice more. These instructions here. Factor completely. factor by grouping completely. So I'm going to scooch up that. Oops, I'm off the screen here. All right, here we go. First, check. Do they have a common factor all the way across other than 1? All 4 terms. No. So the next thing says to arrange, or check to see if the front pair and the back pair have common factors. So look at the front pair. Do they have something in common? How about the back pair? Do they have something in common? Yes. So we are going to split the problems. I always just draw a line after the second term so that I can look at them separately. The first common, you said they had x in common, leaving us with y plus 2. Because you remember you have to be able to distribute it back. And in the second half, they have in common a positive 3. And I want to write that plus 3 there. It's important. Times y plus 2. So we're looking for the magic, and there it is. We have matching binomial factors. So guess what? We can move on. We factor it out. What's their common factor front and back? The binomial factor of y plus 2. The other group, because we're writing it as a product, is x plus 3. Factor. Done. Handled. Next problem. All the way across. Something in common? No. They don't all have x's, and they don't all have y's, and 3 and 4 only have in common a 1. So we're going to cut it in half. Looking at the front, what do they have in common? 3x times x minus 1 in the back. So you want to say positive 4y. You sure you want to say positive 4y? You want to do negative? Okay, I'll back that up. So negative 4y times 1. Nope, negative times negative x. Do you see magic? I don't. X minus 1 is not the same as 1 minus x. This is an addition. We can't just flip them around because that's x minus 1 and negative x plus 1, and they are not the same, which means we didn't find magic. We need to rearrange. Should we rearrange it all, or should we just rearrange the back? So we're going to throw it out and do it again. 3x squared minus 3x plus 4xy minus 4y. Sometimes you got to do it, people. Sometimes you do. So we're going to cut it in half again and start again. 3x times x minus 1. We had that. What do they have in common? Positive 4y times x minus 1. Magic. There it is. It happened. So our GCF is x minus 1. Our other one is 3x plus 4y. And we are out of time, but I do want to talk about C real quick. C is different because all the way across you have a common factor of 2. Factor it out, and then take the remaining polynomial, cut it in half, factor the front, factor the back. So it's going to have 3 factors: a monomial, a binomial factor, and a binomial factor. Tonight's homework is to write a summary on the back if you want to stamp, and problems 1 through 72 on a separate page. Thank you. So for those of you that are still here, we're going to finish up this problem real quick. For problem C, we do have a greatest common factor of 2, so we're going to factor out a 2. Okay, so we factored out the greatest common factor. So now we're going to factor this remaining polynomial by cutting it in half here. So we're going to cut it in half. So we have 2 times, and we're going to factor out the front, a 2a, which leaves us with x minus b. So what we want over here is another x minus b. Let's see if we can make that happen. So if I want to have a positive x out of here, probably should take a negative b out. Negative b times x is negative bx. Negative b times negative b is positive b squared. And so we do have a common binomial factor of x minus b, and the remaining 2a minus b is your last binomial factor. So there you go. Lesson's over. Have a good one.